Welcome back, my lovely students, to our discussion about inverses with matrices. So we defined what an inverse matrix was in our last video, and we looked at how a determinant can help us to determine whether we have an inverse and finding what that inverse is. Today we're going to talk about the formal steps that we need to see to show us that you understand how we're applying inverses. So a thing that mathematicians always do is to solve a complicated problem, we solve an easier problem first. And so this was the problem that we solved in the last video. If I have a real number equation, like 5x equals 10, I have 5 being multiplied by x. In order to isolate x, I'm going to apply the inverse of multiplying by 5. We discussed the inverse of multiplying by 5 is the same as multiplying by 1/5, our multiplicative inverse. If I multiply on one side, I need to multiply on the other side. Multiplication with real numbers is commutative, so it doesn't matter if I do 10 times 1/5 or 1/5 times 10. As we've explored with multiplication for matrices, however, order does matter. So if I have a matrix A times a matrix X equal to a matrix B, in order to get this X matrix, my solution matrix, all by itself, I need to multiply by the inverse of A. Denoted with a -1 up in the sky. This is not to the negative first power. This is just representing that we have an inverse. If I multiply by a matrix on the left, on one side of the equal sign, I must multiply by that same matrix on the left, on the other side of the equal sign. Take a moment, let this sink in. Multiplying by the inverse on the left, because I know A inverse times A gives us our identity matrix times X is going to equal our solution. I could draw a better B, but you know how these things go. All right, let's. So we have a simple system of equations. We've seen ways that we can solve this before using elimination, substitution, and graphing. Now let's convert this into matrices. So I'm first going to make a coefficient matrix. So I have a 1, a -3, a 1, and a -1. I'm going to call this matrix A. 1, -3, 1, -1. I'm going to multiply this matrix by the matrix XY. Because I'm going to get 1 times x, 1 times x, -3 times y, and -1 times y. It's just writing the same thing in a different way. And I know that when I multiply these things together, I'm going to get a matrix that looks like 7, 3. Okay, so I need to multiply, in order to get xy all by itself, which is what I want, I need to multiply by the inverse of this matrix here. When you're working on a test or you're working on homework, you do not need to show me what the inverse is. We have a set number of problems that are specified in your test that'll say, this is where I want you to show me the inverse. Once you've shown me you know how to find an inverse by hand, you can use your calculator as a shorthand. So as a reminder, we need to find the determinant if we're going to do it by hand. We're going to apply our determinant formula. For now, let's just use our calculator. So as we talked about yesterday, you're going to hit a second button to matrix. We're going to edit the matrix that I want. I'm going to call this matrix A. It's a 2 by 2 matrix. So I need to put that into my calculator. This is a 2 by 2 with entries 1, -3, 1, -1. I'm going to get out of matrix mode by hitting second quit, second matrix once more, going over to math. Sorry, let me hit quit again. I'm going to go to matrix A so that I bring up that matrix on my screen, and the button, that the matrix button is underneath to the -1st, which means to find the inverse. I'm finding the inverse of this thing is -1/2, 3/2, -1/2, +1/2. Show me that you found the inverse, that you used your calculator to find this equation, this matrix. Show me that you know that we take this matrix and apply it to this one on the left-hand side. 1, negative 3, 1, negative 1. That's still multiplied by the matrix xy. And you also need to show me that we know to take this inverse matrix and multiply it on the left-hand side. So first I need to put this on the left. Negative 1/2, 3/2, negative 1/2, and positive 1/2, multiplied by 7, 3. Since we multiplied a matrix by its inverse, we know that gives us our identity. We know our identity matrix times another matrix just leaves us with this matrix. So it's enough now to say that we have, let me write this a little bit better, x, y equal to whatever multiplication that we get from this matrix. You don't need to show me negative 1 times 7 plus 3/2 times 3, negative 1/2 times 7 plus 1/2 times 3. You don't need to show me that intermediate step. Show me what happens when we multiply these things together, what my end result is. For the sake of time, I'm going to throw this into my calculator by making a second matrix. I'm going to edit, I'm going to call this matrix B. Matrix B is a 2x1 matrix with entries 7, 3, and then my calculator. I still have my answer here. Let me select that, and then I'm going to multiply that by matrix B, and I see if I have a 2x2 times a 2x1, I should end up with a 2x1, and indeed I end up with a matrix 1, negative 2. So on your test, to get all the points that you need, identify what your inverse matrix is. Show me that you know that you need to multiply your inverse matrix by the original on one side of the equation and on the other, and what that result gives you with your solution matrix intact. Make sure you have all of this copied down in your notes. Make sure you understand the formula for an inverse matrix. If you need to, go back and rewatch Mrs. Caserta's video from the previous part of this lesson before we continue on. When you're ready, let's continue. Thing with this matrix that we just did with our last matrix, pause the video, work through this out. When you're ready, check your answer with what I'm going to put on the board. First thing I'm going to do is I'm going to write my coefficient matrix. I have the matrix 2, negative 5, 3, 4 times the matrix x, y equal to the solution matrix for this particular system of equations, 8, negative 6. Maybe in my head I'm going to think about, does this have an inverse? Is this a solution? Does this have a solution? 2 times 4 is 8. 3 times negative 5 is negative 15. 8 minus negative 15, it's not 0. I do have an inverse. I can go ahead and proceed. Alright, so I'm going to go into my calculator to figure out what the inverse of this matrix here is. I can still call this matrix A. It's still a 2x2, but I need to re-enter my entries. Negative 5, 3, and 4. Second quit. Second matrix A, because that's what I called it. Inverse button. I'm finding the inverses. Ooh, some really ugly decimals. But we know that we can go into math, hit our fraction button to get our inverse as 4/23, 5/23, negative 3/23, and 2/23. I know that I need to multiply by inverse matrix by my original matrix. 2, negative 5, 3, 4. Our xy matrix is still along for the ride. And I know that I applied this inverse matrix on the left, so I need to continue applying this inverse matrix on the left in a multiplicative fashion. Times what we had earlier, 8, negative 6, I know an inverse times its original matrix, or a matrix times its inverse, is still going to be the identity matrix. The identity matrix times any other matrix is that matrix, x, y. I'm going to throw this into my calculator. You don't have to show me the rows times the columns. So let me put in that this is a new matrix. I'm going to edit matrix B. Instead of the last matrix, we are going to have 8 and -6. Second quit. So we do matrix A inverse times matrix B. My final solution is again some ugly fractions, so I'm going to hit my fraction button to find out that my final answer is 223, -36, 23. This is the x value that satisfies this system of equations. This is the y value that satisfies this system of equations. Check your work with what you've come up with. If you have any questions, make sure that you talk to us in class. All right, let's see what our next page has for us. So flip your notes over. Again, we can continue to use our graphing calculator to solve these systems of equations. So if I have a system of equations, I can break this up into my coefficient matrix, my xy matrix, and my solution matrix, 8 and -6. And so I know that if A times x gives me B, then x would be A inverse times B. That's just what we were showing on the previous area. So again, using our matrix menu, this is just what I'm doing, just now written into words. We enter A and B into our graphing calculator. We do A, inverse button, B, to solve for x and y. That's exactly what we did on the last slide, so let's look at a more complicated example. A 3-variable system. This was all that we did in the last chapter, so let's see. If I want to write A as my coefficient matrix, we have 5, 2, -1, 1, -2, 2. I don't have an x value. Well, what times x makes x disappear? I'm going to put in 0 for my matrix. Don't just start putting down 3, 1, 17, and then 17 again in your B matrix. Be careful. Make sure every entry is accounted for. 3, 1. Our solution matrix is -7, 0, 17. -7, 0, 17. A inverse, I'm going to put this into my calculator. I'm going to figure out B as well in my calculator. So let me take a moment here to do that. Matrix A now, instead of a 2 by 2, is going to be a 3 by 3 with entries 5, 2, -1, 1, -2, 2, 0, 3, and 1. And now let me also edit what B is. B is no longer 2 by 1, but 3 by 1 for my calculator. So that's -7, 0, 17. I'm ready to go back to my home screen. Matrix A, inverse button, matrix B. I can see x is equal to A inverse B, which is going to give me -2, 4, 5. Maybe I've made a mistake. Maybe this doesn't make any sense. I have a 3 by 1 matrix. Well, I multiplied a 3 by 3. Its inverse is still going to be a 3 by 3. So I multiplied a 3 by 3 matrix by a 3 by 1 matrix. The 3's match, and I'm left with a 3 by 1 matrix. Oh, I am supposed to be left with a 3 by 1 matrix. So I have an x value that satisfies this system, a y value that satisfies this system, and a z value that satisfies this system. In this to try on your own, show us when you come to class that you've figured this out. Find your coefficient matrix, figure out I'm getting tongue-tied here. Find your coefficient matrix, find the inverse of that coefficient matrix, multiply that by your solution matrix to get a matrix that just tells you what x, y, and z are. Show us this when you come into class tomorrow. You get a sticker.